So class, good day. So now let's have the last topic of CE 335, which is the Engineering Utilities 2. So for the last topic, let's have the HVAC. This is for mechanical part of the buildings. So HVAC abbreviation means heating, ventilation, and air conditioning. Okay. So for the definition of air conditioning, so this is the simultaneous control of temperature, humidity, motion, and purity of the air in a confined space. So normally we use air conditioning unit as an artificial ventilation system of specific rooms or confined space areas. And then we have the functions or elements of air conditioning. First is the cooling and dehumidifying of air, and then heating or humidifying of air. And then also we have the cleaning of air or filtration. And number 4, we have the circulation of air. So for the air conditioning standards, we have for the cooling and dehumidifying. So for summer cooling, temperatures of 68 degrees to 74 degrees Fahrenheit and 50% relative humidity are a frequent design average. So this is for summer cooling. And then for heating and humidifying, for winter cooling, the temperature is 70 degrees to 75 degrees Fahrenheit, and relative humidity is as 30% to 35% are found most satisfactory. Next is air motion. So air velocity should have an average of 4.57 to 7.6 meters per minute, measured 36 inches above the floor. And then for the air supply, so letter A, for a 5 cubic feet to 7.5 cubic feet of air per minute per person, or that is 5 to 7.5 cubic feet per minute per person. So in rooms where smoking is not allowed. And then for 25 cubic feet to 40 cubic feet of air per minute per person allowed in room where smoking is permitted. Okay. So it depends if that is a smoke area or a non-smoking area. Okay. The next is the method of cooling and dehumidifying. So first is passing the air through a spray of cold water. So this is the diagram for the air handling unit, AHU. And then number 2 is passing the air through coils containing cold water. And number 3, passing the air through coils containing the refrigerant itself. In this case, the coils are called direct expansion coils. And number 4, the passing the air through a combination of sprays and coils. So more likely you have seen a door with a label AHU in malls. So that is for the air handling units. No? So this is the diagram for the air handling units. So more likely for the exact discussion of this topic is through mechanical engineers. So we will just have the basics. Next, we have the refrigeration cycle. So first you have a freon. So it is a gas at normal temperature and pressure. It is first subjected to high pressure in a compressor which raises its boiling points and temperature. So freon can cause the area cool. No? So that's the use of freon. So at the same time, high pressure, the vapor is piped into condenser coils where it is cooled by water to a degree below its liquefaction point. So it condenses into a liquid state and still under a high pressure passes to the evaporators. And then number 3, In the evaporator, the pressure is relieved by a suction stroke of the compressor. So the boiling point of the liquid refrigerant drops and evaporation into a vapor takes place. So the water which surrounds the evaporator coils gives up its heat in causing the evaporation at a low pressure, thus reducing its temperature to the temperature of the refrigerant. So the cold water can then be piped at a low temperature to any desired point and sprayed to cool the passing air. So the refrigerant is sucked back into the compressor and the cycle commences. So this is the diagram of the refrigeration cycle. So first you have the cold water and then pass to the compressor or the condenser. And then you have the expansion valve for the gas evaporators. So also going to the compressor, you have here the warm water return. And then this one is the cold or chilled water. So from cold water to the chilled water. So this is the refrigerating or the cooling unit figure, this one. So Freon class is a refrigerant used for cooling. So mechanical refrigeration is based upon the alternative liquefying and evaporating of a volatile liquid with a low boiling point, usually Freon 12, or that is the dichloro-difluoromethane or the Freon 11, that is the trichloromonofluoromethane. So during which processes it respectively gives off and takes in heat. The desirable properties of Freon are A, you have high heat of evaporation, moderate pressure change for low to high temperature range. This is also a non-toxic, incombustible, non-explosive, and non-corrosive. So that is Freon. Next, we have the type of air conditioning system. So for the type of air conditioning system, you have the centralized system or central system. You have the split type air conditioning system and the window type air conditioning system. So for the central system or the centralized air conditioning system, so all season centralized air conditioning system consists of the following. A method of cooling or a refrigeration plant. So this one, a refrigeration plant. And then B, a source of heating such as boiler or furnace. And then C, air handling unit. So this is normally used in department stores, the centralized air conditioning unit or air conditioning system. And then D, the air distributing equipment composed of air conducts, fans, and air outlets. And letter A, the necessary manual or automatic controls. Okay, so that's for the centralized air conditioning unit. So more likely, this is for mechanical engineers. So as we civil engineers, we can at least design an window type air conditioning unit or a split type air conditioning unit. So number two is the split type air conditioning unit composes of the air conditioning condensing unit and a fan coil unit. So FCU and the ECCU. So this is a split type air conditioning unit. So outside the building, you have the ECCU, the air conditioning condensing unit. And inside the building or inside the room, that is the FCU, that is the fan coil unit. Next, we have the window type air conditioning system. So the normal air conditioning that we use in residential building and maybe in commercial building. So composes of the condenser coil. So you have the exterior air and then the compressor, also the room air, going to the compressor, and then evaporator or fan and motors. So you have here the cold air. So evaporator coils, direct expansion coils. And then this one is for the condenser coils, air cooled. So this is the diagram of the window type air conditioning unit. This one. So air conditioning equipment. So the first is the refrigeration plant. So composes of compressor, condensers, evaporators. So first is the compressor. So you can have a piston type or reciprocating compressor for tonnage up to 100 tons. And then you can have also a centrifugal compressor. These are quieter, have fewer vibration problems, require less maintenance, and with better operation control. So this is for the compressor. And then let's have now the condensers. So letter A is the air-cooled condenser. So used in and package type air conditioners up to 3 tons refrigerations. So this is used in uh, window type air conditioning system or unit. And then we have also water cooled condensers, double pipe condensers, this one. This is used in refrigerators, water cooled condenser. So we have also a shell and tube condenser, this one. Cooling water, vapor refrigerant, liquid refrigerant, and then the warm water. Another is evaporative condenser. You have hot air, uh, you have a fan, condenser coils, and the cold air. And last, for the refrigeration plant is the evaporators. So for shell and tube heat exchanger, similar in operation to the shell and tube condenser, the refrigerant is expanded into a shell enclosing the tube through which the water flows. And also you have direct expansion coils or coils containing the refrigerant itself. This may either be installed in spray chamber so that the water sprayed into the air comes into contact with cooling coils, or the air itself comes into direct contact with the cooling coils as in the window type unit. So that's the evaporator used in window type air conditioning units. Next, we have cooling and dehumidifying equipment. So you have water sprays and cooling coils. And then for heating and humidifying equipment, you have tempering coils and water heaters. So for tempering coils that contain steam and are used to heating the air, for example, preheaters and preheater. And then for water heater, used for heating the water which will be used in the spray chamber to add heat and humidity to the air. And then you have for the air cleaning equipment, we have the filters. So there are at least 4 filters. The dry filters, which consist of a wire frame enclosing felt cotton or sponge through which the air is screened. And then you also have the viscous filters, consist of metal deflecting plates or screens coated with viscous oil. We also have water sprays, and the eliminator plates consist of corrugated galvanized iron sheets placed 1 and 1/8 inch apart, which deflects the airflow about 30 degrees, catching the wet dust on the surface. So this is the illuminator plates, this one. So next we have the air distribution equipment. So for the air distribution equipment, we have the air conditioning ducts. So are usually of galvanized sheets, metals, or aluminum sheets, usually rectangular or in section, depending on the aspect ratio. Although circular ducts are also used for high velocity system. So in CIT gymnasium, we have circular ducts. Okay. Also in Landers and SNR, they have circular ducts for their centralized air conditioning unit. Okay, so for the aspect ratio, the ratio of the long side to short side not to exceed 5:1, although 4 or 3:1 is preferred. So this is the sample drawing of ducts from the maybe from the central or from the air handling unit to the ducting. Okay, so this is the diagram or figure. Next, we have fans. So there are two types of fans, the centrifugal fans or the radial fans. These are intended for moving air, are comparatively high pressure, and are commonly used in duct system. We also have propeller or axial fans, commonly used for wall exhaust. This is for exhaust fan. And then we have air outlets. So these are made up for two locations, walls and ceilings. So they have two types. So for walls, that is vane outlets or perforated grills. And then for ceilings, that is flux, perforated panels, and perforated ceilings for the air outlets. So next we have the control equipment. So you have sensing devices and actuating or operating devices. So for humidistat or the hygrostat is a controller sensitive to the amount of humidity in the air. Also, we have the thermostat, usually used in window type air conditioning unit, the thermostat. So a controller which responds to the changes in temperature. And then we also have pressure regulators, are instruments sensitive to the changes in pressure. They may control a single pressure or a differential between two pressures. And then number two, we have the actuating or operating devices. First is the dampers. These control the flow of air and are in the form of louvers. And then letter B is the control valves. These are valves with variables orifices which are moved by motors to present smaller or larger openings as directed by the thermostat. And then we have relays. These are devices that use electrical energy to amplify or convert the power of a thermostat or other controller so that the resultant force will be sufficient and adaptable to operate the valve, to operate a valve or a damper. And then we have now for the heating systems. So in the Philippines, I think we don't have the heating system since our weather here in the Philippines are, I think, but sometimes in sauna, no, you have sauna for the heating system. So for the centralized system for heating, we don't have here in the Philippines, but in some cases I think they have the heating system. So for the type of heating system, we have mechanical warm air heating system, steam heating system, hot water heating system, and the radiant panel heating system. So for the mechanical warm air heating system, heating medium is the air. The heating device is you have furnace. The method of air handling is ducts. And the method of distribution, you have the registers. For the steam heating system, for the heating medium is the steam. The heating device is the boilers. The method of handling is pipes. And the method of distribution is radiators. And then for the hot water heating system, you have the heating medium is water. The heating device is the water heater. Maybe this is for hot water heating system for water distribution system. And then the method of handling is pipe, and the method of distribution is radiators. And then for radiant panel heating system, the medium heating is water, air, and electricity. For the heating device, you have the water heater, furnace, and electric heaters. And then for the method of handling, you can have pipes. Then for air is ducts. And then for electricity, you have wires. So for water, the method of distribution is for ceiling or floors. And then for air, you have ceiling, and electricity for ceiling. So you just go through with these slides, class. I already gave you the notes for this, no, for the resource. So this is for mechanical warm air heating system. So this is the diagram. And then for steam heating system, there are two types. You have air vent system, that is the one pipe gravity system. And then the other one is the vacuum system, or the two pipe steam heating system. So this is the diagram. So maybe we don't understand the diagram as to we are civil engineers, but to the mechanical engineers, they can discuss this further for as they study this type of diagrams. Okay. Next, we have the hot water heating system. So there are also two types. So you have the one pipe hot water heating system and the two pipe hot water system. Okay. So this is the diagram. Next, we have the radiant panel heating system. So you have there the diagram. So take note that pipes may also be installed at the floor for the radiant panel heating system. Okay, now let's have the provisions from the National Building Code concerning the HVAC, or the heating, ventilation, and air conditioning. So for the definition used in the provision, you have the accidental contact. So any inadvertent physical contact with power transmission equipment, prime movers, machines, or machine parts which could result from slipping, falling, sliding, tripping, or any other unplanned action or movement. And then you have air conditioning. So this is the process of treating air so as to control simultaneously its temperature, humidity, cleanliness, and distribution to meet the requirements of the conditioned space. And then boiler, a closed vessel for heating water or for application of heat to generate steam or other vapor to be used externally or to itself. Then we also have a capacity of work project or plant, the total horsepower of all engines, motors, turbines, and other prime movers installed whether in operation or not. And then we have compressor. This is a mechanical device for the purpose of increasing the pressure upon the refrigerant. Then condenser, it is a vessel or arrangement of pipes or tubing in which vaporized refrigerant is liquefied by the removal of heat. And then you have a condemned boiler or unfired pressure vessel. It is a boiler or unfired pressure vessel that has been inspected by the building official and declared unsafe or disqualified, and power stamp or mark designating its rejection. And then we also have a crane, means a machine for lifting or lowering a load and moving it horizontally, the hoisting mechanism being an integral part of the machine. So we also discussed this in building conveying system. Next, we have duct. So a passageway made of sheet metal or other suitable materials, not necessarily leak tight, for conveying air or other gases at low pressure. And then we have enclosed, means that the moving parts of a machine are so guarded that physical contact by any part of the human body is precluded or prevented. This is also discussed in building conveying system. Next is evaporation. So that part of the air condition or refrigeration system in which liquid refrigerant is vaporized to produce refrigeration. And then you have external inspection. So it is an inspection made on boiler during operation. And then you have guarded. We also discussed this in building conveying system. Next is internal inspection. So it is an inspection made when a boiler is shut down with hands holes, manholes, or other openings open or removed to permit inspection of the interior. Next is a liquid receiver. So a vessel permanently connected to a system by inlet and outlet pipes for storage of a liquid refrigerant. And then locomotive boiler. So a boiler mounted on a self-propelled truck locomotive used to furnish motivating power for traveling on rails. Another is a low pressure heating boiler. It is a boiler operated at a pressures not exceeding 1.05 kilogram per square meters with steam or water temperature not exceeding 250 degree Fahrenheit. Then you have a machine that is driven unit of an equipment. And then a machine house, machine part, mechanical work plants. So this is already discussed in building conveying system. Then we have the point of operation. So that part of a machine which performs an operation on the stock or material and or that place or location where stock or material is fed to the machine. A machine may have more than one point of operation. Then we have also portable boiler, an internally fired boiler which is self-contained, primarily intended for temporary location. And then we have prime mover, an engine or motor operated by steam, gas, air, electricity, liquid, or gaseous fuels, liquids in motion, or other forms of energy whose main function is to drive or operate either directly or indirectly other mechanical equipment. You have also process machines, so an equipment designed and operate for a specific purpose. And then we have refrigerant. So it is a substance which produces a refrigerating effect by its absorption of heat while expanding or evaporating. Then ton of refrigeration. So the useful refrigerating effect equal to the 12,000 BTU British thermal unit or BTU per hour, or that is 200 BTU per minute, or BTU is British thermal unit. Next is unfired pressure vessel. So a vessel in which pressure is obtained from an external source or from an indirect application of heat. And then last is the ventilation. So last from the definition of terms used in the provision of the National Building Code concerning the HVAC. So for the ventilation, this is a process of supplying or removing of air by the natural or mechanical means to or from any space. So for the provisions of boiler and pressure vessels, first is the location of boilers. So boilers may be located inside the buildings provided that the boiler room is of reinforced concrete or masonry and that the boiler room shall be used for any other, shall not be used for any other purpose. So for that particular room, it should only be the boiler's location, or the boilers is placed in that particular room. So no other purpose made for that room. And then in case the main building is not made up of fire-resistive materials, boilers shall be located outside the building at a distance not less than 3 meters from the outside wall of the main building, and the building housing the boiler shall be made up of fire-resistive materials. And then letter C, no part of the boiler shall be closer than 1 meter from any walls. And then letter D, fire tube boilers shall be provided with sufficient room for removal, replacement of tubes either through the front or rear. So that's for the location. So number two, you have a smokestacks, whether self-supporting or guide, uh, shall be of sufficient capacity to handle fuel gases, shall be able to withstand a wind load of 175 km per hour, and shall rise at least 5 meters above the eaves of the building within the radius of 50 meters. Sorry, 50 meters. Number three, manufacturers, assemblies of boilers, pressure vessels, pressurized water heaters shall stamp each vessels on the front head or on any other suitable location with the name of the manufacturer, serial numbers, maximum allowable working pressure, heating surface in square meters, and year of manufacture. So normally, when we buy boilers or tanks, it should have the stickers, no, which have the name of the manufacturers, the year of manufacture, maybe materials used for manufacturing of that particular boiler. And then number four, boilers of more than 46 square meters heating surface shall each be provided with two means of feeding water, one steam driven and one electrically driven, one pump and one injector. The number five, two check valves shall be provided between any feed pumps and the boiler in addition to the regular shut-off valve. So if you have a boiler, you should have at least two check valves installed in each boilers. And then where two or more boilers are connected in parallel, each steam outlet shall be provided with a non-return valve and a shut-off valve. So this is the provision from the National Building Code. Then boiler room should have at least two separate exits. So you have two emergency exits. And then number eight, in no case shall the maximum pressure of an old existing boiler be increased to a greater pressure than would be allowed for the new boiler of same construction. And number nine, each boiler shall have at least one safety valve. So for boilers having more than 46 square meter pressure, a water heating surface, or a generating capacity exceeding 907 kilogram per hour, or two or more safety valves shall be required. And then number 10, each boiler shall have a steam gauge with a dial range of not less than 1.5 times and not more than twice the maximum allowable working pressure. It may be connected to a steam space or to the steam connection to the water column. Number 11, whenever repair replacement are made on fittings or appliances, the work shall comply with the section on new installation of the Philippine Mechanical Engineering Code. And then number 12, after a permit has been granted to install a boiler, pressure vessel, or a pressurized water heater upon payment of the installation fees thereof, it shall be the duty of the building official to make periodic inspection of the installation of the to determine the compliance with the approved plans and specifications. So upon the permit is granted, so there should be an inspection periodically by the building official. And then number 13, upon the completion of the installation, the building official shall conduct the inspection and test. Also, the mechanical engineers who sign and seal the plans can also inspect and conduct inspection of that particular installation. And then number 14, the building official shall notify the owner in written of the intended date of the annual inspection at least 15 days in advance. And then number 15, the owner or user of the boiler shall prepare the same for inspection by cooling it down, blanking of all connections to adjacent boilers, so removing all soot and ashes from tubes, heads and combustion chamber. So the owner shall assist the building official by providing all labor and equipment required during the said inspection. So next we have the refrigeration and air conditioning. So from the provision in the National Building Code, so the temperature and humidity of the air to be used for uh, comfortable cooling shall be maintained at 67 to 74 degree Fahrenheit. Effective effective temperature at an air movement from 4.57 to 7.60 meters per minute. I think that's meters per minute. So try to check lang MPM plus and within the living zone. And then water from evaporators, condensers, and other machinery shall be properly collected into a suitable water or drainage system. So ducts shall be constructed entirely of non-combustible materials, so such as steel, iron, aluminum, or other approved materials, which is fire resistant. The only fire retardant linings of shall be used on the inside of the ducts. And then access doors shall be provided at all automatic dampers, fire dampers, thermostats, and other apparatus requiring service and inspection in the duct system. And then number 5, you have wire where ducts. Okay, so number 5, so where ducts pass through walls, floors, or partition, the space around the duct shall be sealed with a fire-resistant material equivalent to that of the wall, floor, or partition to prevent the passage of flame or smoke. So wind ducts or other outlets or inlets to them pass through walls, they shall be provided with automatic fire dampers on both sides of the wall through which they pass. And then number 7, fire doors and fire dampers shall be arranged to close automatically and remain tightly closed upon the operation of a fusible link or other approved heat actuated device located were readily affected by an abnormal rise of temperature in the duct. Okay. And then number 8, each refrigerating system shall be provided with a legible metal sign permanently attached and easily accessible, indicating thereon the name of the manufacturer or installer, kind and total number of kilograms of refrigerant contained in the system, and the field test pressure applied. Then number 9, you have in refrigerating plants or more than 45 kilogram refrigerants, masks and helmet shall be used. These shall be these shall be kept in a suitable cabinet outside the machine room when not in use. So you have the protective equipment. And then not more than 136 kilograms of refrigerant in approved container shall be stored in a machine room at any given time. Number 11, where ammonia is used, the discharge may be into a tank of water which shall be used for no other purpose except ammonia absorption. So at least 1 gallon of water shall be provided for every 0.4536 kilogram of ammonia in the system. Number 12, refrigerant piping crossing a passageway in any building shall be less than 2.3 above the floors. Okay, and then number 13, in a refrigerating system containing more than 9 kilogram, stop valve shall be installed in inlets and outlets of compressor outlets, of liquid receivers, and in liquid and suction branch heater. Number 14, window type air conditioning systems shall be provided with drain pipe or plastic tubing for discharging condensate water into a suitable container. So mostly as to window type air conditioning units, we have a tube connected to the condensate water. No? Uh, in It should be collected through a suitable container or maybe connected to your catch basins or pipe going to your catch basin. And then for number 15, window type air conditioning units installed on ground floors or building shall not be less than 2.13 meters from the ground. So the height of the window type aircon is 2.13 meters from the ground. Okay, then window type aircon shall be provided with exhaust ducts if the exhaust is discharged into corridor, hallways, arcades, or sidewalks. Then number 15, window type aircons installed along corridors, hallways above the first floor shall not be less than 2.13 meters above every floor level. Next, we have the pipings. The pipings used in HVAC. So normally, there are pipes used in heating, and also if you use a split type aircon, you use pipelines. The piping shall, as much as possible, run parallel to the building walls. Group piping shall be supported on racks on either horizontal or vertical planes. Also, you have pipings on racks shall have sufficient space for pipes or chain wrenches so that any single line can be altered, repaired, or maybe replaced without disturbing the rest of the pipelines or the pipings. And then number 4, piping 100 millimeter in diameter and above shall be flanged. Smaller size pipe may be screwed. So next, number 5, piping subjected to varying temperatures shall be provided with expansion joints. Number 6, galvanized piping shall be used for steam. Number 7, piping carrying steam, hot water of hot liquid shall be embedded in concrete walls or floors and shall be properly insulated to prevent accidental scalding to person and to minimize heat loss. Number 8, you have also a color coding of pipelines based on the National Building Code. So you have for steam division, that is white for high pressure, and then buff for exhaust system. For the water division, you have blue for fresh water or for the low pressure fresh water. Also, we have blue for high pressure fresh water. And then green for the salt water piping. But for the PPR class, the color of the PPR pipe is green. But we use that for fresh water. So it's up to the owner or maybe the contractor what color of pipe they will use for the fresh water of the water division. Next, we have the oil division. So you have the brass or the bronze pipe for the delivery of oil division. And then for the discharge, you have a color yellow. And then for pneumatic division, you have for the oil piping, you will have to use the color gray, or maybe you can paint all the piping by color gray. And then for the gas division, you have black, also for the fuel oil division. And then for the refrigerating division, for pipes, you have black, and then for fittings, you also have a black color for the pipings. Then you have here the heating and ventilation symbols. So mechanical uh, in planning a mechanical plan, you have all the symbols maybe corresponding to your legend, not necessarily following this type of symbols. So if you have another type of symbols, so you just have to have a legend so that we can directly read your mechanical plans corresponds to the legend. So, but in this case, we have heating and ventilating symbols, this one. We just go through with these slides, class. You can use this if you want to have a mechanical plan of your building. This one is for ductwork symbols. This one is for heat power apparatuses symbols. This is for refrigeration symbols. So this is used mostly in this is used mostly for mechanical engineers. At least we know the symbols used for mechanical plants. Okay, so that's all, class, no? So this ends our discussion for this subject, CA 335. So thank you and good day.